Hey everyone, today we're going to be doing this integral for with u-substitution, integrating it with just u-substitution. So let's get started. We have the indefinite integral of 2x over x squared plus 1 dx, and I've already boxed out this x squared plus 1, because that's what we're going to be defining as u for u-substitution. So u is equal to x squared plus 1. And now from here we can define a couple extra terms just off this. This is why one of the most powerful integration techniques. We'll be showing how this kind of relates to chain rule afterwards. So we can differentiate both sides. We get du, it's a bad looking u, it looks like a 4. Du is equal to 2x dx, because the derivative of 2, or rather x squared is just 2x, and 1 is 0, it's constant. And now du over 2x equals dx. Simultaneously, we can also define what x is in this. Because we have u equals x squared plus 1, we can simply subtract 1 from both sides. We get u minus 1. Take the square root of that, and you get square root of u minus 1 equals x. So now we're ready to bring this integral into the u world. So instead, we're going to replace every x with a u, and so we would have the indefinite integral of 2 times square root of u minus 1 over u, and then we would have du. And now we could replace it with dx with du over 2x, but we'd still have an x, which isn't so great. So instead, we're going to use square root of u minus 1, so we would have it over 2 times the square root of u minus 1. Now this is great because these two cancel out. What we're left with is just an integral that we actually can evaluate. So the definite integral of just 1 over u du. Now, we think what thing's derivative is 1 over some variable. Well, we know the natural log, or ln. So we can just integrate this into ln, that's a bad looking n, ln of u. Now we're not done just yet, because since we integrated into the u world, we now have to substitute back out into the x world, which is pretty easy in this case. It's just ln of u, and remember we defined u to be x squared x squared plus 1. So this just becomes ln of x squared plus 1. Don't forget the plus c for your integral, since this was indefinite, and that's your answer. That's how to integrate this. And now, just to check, and just to sort of prove a point that u-substitution is almost like reverse chain rule, we're going to be defining some function, f of x, to be ln of x squared plus 1. Now, how do we differentiate this? Well, f prime of x, in this case we would have to use the chain rule. So the way we do that is we take the derivative of the inside function, which in this case is just 2x, and we multiply it. So we'll just bring it to the outside, 2x times, and then we take the derivative of the whole outside function, leaving the inside the same. So in this case, the derivative of ln of something is always just 1 over that something. In this case, that something is x squared plus 1, which, of course, we multiply it out. We get 2x over x squared plus 1. And so we have shown here that u-substitution is pretty much like a reverse chain rule for integration, very similar to how reverse power rule in integration is adding 1 and then dividing it, whereas differentiation with power rule is subtracting 1 and multiplying it. So they're pretty much just inverses of each other. It's a little less obvious with u-substitution, but I hope I showed that. Yeah, thank you for watching.